Law of cosines is another way that we can solve triangles that don't have a right angle. For example, this triangle where the sides are lengths 3, 5, and 7. Notice I don't know an angle, none of the angles. Remember, with the law of sines, we had to know an opposite side and its opposite angle. So we can solve different kinds of triangles with the law of cosines. And the law of cosines looks like this. We take one of the sides squared, and that has to equal the other side squared plus yet the other side squared. So far it looks just like the Pythagorean theorem. Now minus 2 times the other two sides times the cosine of what angle goes with this. So A goes with angle A. And we can set this up for starting with either A, B, or C, and it's always the same pattern. You get one side squared equals sum of the other two sides squared minus 2 times the other two sides times the cosine of the angle that goes with the side that you started. So here are the other two versions. Starting with B squared, it equals A squared plus C squared minus 2 times A times C times the cosine of the angle that went with this, B. And the third one, we can start with C squared equals A squared plus B squared minus 2 times A times B times the cosine of angle C. So using one of these three, you can always solve for a different thing. Right, so starting with this version, if you look at what we know, I know A, I know B, I know C, so that gives me everything in this equation except for the cosine of A, which means I can now solve for the cosine of A, then use inverse cosine to actually find angle A. So now it's simply a matter of plugging in these numbers, grinding out a solution. So here A is 5, so that's 5 squared, equals B squared, which is 3 squared, plus C squared, which is 7 squared, minus 2 times 3 times 7 times the cosine of A. So 5 squared is 25, 3 squared is 9, 7 squared is 49, minus 2 times 3 is 6 times 7 is 42 times the cosine of A. Now, when you get to this stage, a common mistake is to think you can subtract these. Well, you can't. In this case, cosine of A is like the variable. So this is similar to, say, 3 minus 5x. I can't subtract these two because they're unlike terms. This one doesn't have an x, this one does. Alright, so keeping that in mind here, I've got 25 equals 9 plus 49, which is 58, minus 42 cosine of A. So I need to get rid of this 58 and this negative 42, so I have to subtract this. So 25 minus 58 equals negative 42 times the cosine of A. And then I now have to divide by this. So I have 25 minus 58 divided by negative 42 equals the cosine of A. Alright, so we can do this arithmetic, and 25 minus 58 is negative 33 over our negative 42. Since these are both negative, I got negative divided by negative, I can just consider this to be positive. So I now know the cosine of A, so using inverse cosine, I can get angle A. So angle A is equal to the inverse cosine of 33 over 42. Now 33 over 42 will reduce, but you could go ahead and reduce it, but if I find the inverse cosine of this equivalent fraction, I still get angle A. And angle A comes out to be approximately 38, excuse me, 0.2132 degrees. So now I have one of the angles. Now notice that now that I have an angle, I could, if I wanted, use the law of sines, because I now have a side and its opposite angle. But most people with a problem like this prefer to just do the law of cosines again with one of the other sides. That way you've got two angles, take those two away from 180 to get the third. Alright, so now to get one of the other sides, I'm going to, instead of use that version of the law of sines, I will instead use the one that starts with b squared. So plugging in my values, I've got b squared, which is 9, equals a squared, which is 25, plus c squared, which is 49, minus 2 times a, which is 5, times c, which is 7, times the cosine of angle b. And grinding these things out now, 9 is equal to 14, 5, 6, 74, minus 2 times 5 is 10, times 7 is 70, minus 70 cosine of b. So subtracting this, dividing by this, I have 9 minus 74 over negative 70 equals my cosine of b. Okay, so 9 minus 74 is negative 65 over negative 70. It's equal to cosine of b, both negative again, so I can consider this to be positive. And now by finding the inverse cosine of that, 65 over 70, I'm going to get angle b. It's inverse cosine. I'm finding an angle. Once again, this I could reduce this fraction if I wanted, but the equivalent fractions, the inverse cosine of that is going to be the same. Alright, so that comes out to be approximately 21.7868 degrees. So I now have both angle A and I have angle B. So if I take these two values, subtract them away from 180, I'm going to have my angle C. So my angle C ends up being approximately 120.0000. Comes out almost perfectly even degrees. So I now have all three angles in my triangle.